Welcome back. Algebra 2, we're in lesson 107. We're going to talk a little bit about number word problems. The value of a digit in a decimal number depends on the position of the digit with respect to the decimal point. So in 496.0, the value of 6 is 6 times 1 because it is in the ones place. And the value of the 9 is 9 times 10 because it's in the tens place. And the value of the 4 is 4 times 100 because it's in the hundreds place. We can use the fact that the value of a digit depends on its position to solve some rather interesting word problems. To solve these problems, we will use U to represent the ones place, T to represent the tens place, and H to represent the hundreds place. So U stands for units. We don't want to use a O for 1 because it might be confused with a 0, and we don't want to bring any confusion. So that's why we're going to use U for individual units. So keeping that in mind, let's look at 107.1. Let me put this up here for us. All right, here's the first problem. The sum of digits in a 2-digit counting number. Okay, so 2-digit counting number. Counting number, that's a natural number, so we know it's positive. The sum of the digits in a 2-digit counting number is 11. So that tells us we can create a equation. The units plus the tens place is equal to 11. If the digits are reversed, the new number is 27 greater than the original. What is the original? So if the digits are reversed, so let's create a value equation based on that. So we know that 10 times t, that's in the tens place, plus u, that's the original number with the tens in the tens place and the u in the u's place. If we reverse that, so that means that we have to change the location of the u number. We have to put it in the tens place. So we're going to say 10 times u plus t. That is 27 greater than the original. This is the original. So we got to add 27 to the original. Sorry. Is 27 greater than the original? So that means we need to add 27 to the original number to make them equal, right? This one's already 27 greater than the original, so we add 27 over here to make them balance. Now we can solve this. So what we're going to do is we are going to create a substitution here by saying t is equal to 11 minus u, because we subtracted u from both sides. So now we have a substitution value for t. So we can go ahead and put that in here. 27 plus 10 times 11 minus u plus u is equal to 10 times u plus 11 minus u, because that's the value of t. So we are going to now multiply 27 plus 110 minus 10u plus u is equal to 10u plus 11 minus u. So let's combine like terms. So this is going to be 137 minus 9u is equal to 9u plus 11. Let's see. So if I subtract 11 from both sides and I add 9 to both sides, 9u, I get 126 is equal to 18u. So I'm going to divide both sides by 18. And let me get my calculator. 126 divided by, I typed the wrong number. 126 divided by 18 is equal to 7. So 7 is equal to u. So if I sub in the value of 7 here, t is equal to 11 minus 7, which is equal to 4. So t is equal to 4. So the original arrangement is going to be TU, tens and units. So if t is equal to 4, that's going to be a 4, and if u is equal to 7, the original number is going to be 47, and that is correct. All right, was that super confusing? Maybe a little bit. Let's do another one and see if we can clarify it. So let me clear this, and I'm going to write the next one on the board. All right, here's our second example problem. The sum of the digits of a two-digit counting number was 9. When the digits were reversed, the new number was 45 less than the original. What was the original? So let's analyze this. So we know that it's going to be a natural number because it's a counting number, so that means it's a positive integer. So our original number is going to look like this. It's a two-digit counting number, so it's going to be t for tens and u for units. And that is the original. So we also know that the sum of those two was 9. So t plus u is equal to 9. And that also allows me to write an equation where I can substitute by subtracting u from both sides. I can say that t is equal to 9 minus u. So now I have a substitution value for t. Okay, so now let's look at the second sentence. When the digits were reversed, the new number was 45 less than the original. So now we're talking about the value of the number. So the original value was 10t, 10 times t plus u, however many units that was, right? So when the digits were reversed, so that means it would be 10u plus t, as written as a ones place. The new number, that's this one, so I'm sorry, that'd be 10u plus t. The new number was 45 less than the original. So we have to take the original and subtract 45 from it. So minus 45 from the original so that it equals the new number. Now we can solve. We have a substitution value for t, so let's drop it in and rewrite. 10 times 9 minus u, because that's the value of t, plus u minus 45 equals 10u plus the substitution value for t, 9 minus u. So we have 90 minus 10u plus u minus 45 equals, this would be 9u plus 9. This would be a negative 10, negative 55. No, I'm sorry. That's a 10u. So that would be negative 9u, and 90 minus 45 is a positive 45, equals 9u plus 9. So if I subtract 9 from both sides, and I add 9u to both sides, that cancels, that cancels. 45 minus 9 is going to be 36, is equal to 18u. If I divide both sides by 18, I find that 2 is the value of u. All right, so if this is the value of t, 9 minus 2 is equal to 7. So in the original equation, or the original number, t is 7 and u is 2. So the original number was 72, and that is correct. All right, so does that make more sense? We first start by writing the number the way it's supposed to look. Then it says the sum of the two digits. So we add those digits together and we take whatever that value is here. Now we write a value statement, and the value statement is going to be 10 times the tens place, and there's an invisible 1 here, 1 times the ones place, which is units, right? And then whatever this says about the reversal, when the digits were reversed, okay, so if the digits were reversed, now we say 10 times u and 1 times t, because the value is reversed, and because their places are reversed. So it went from looking like TU to UT. So that is the reversal that it's talking about. It's almost like a transposition of numbers. It is a transposition of numbers. So we have to think about it in those terms. So when the digits are reversed, it reverses their value. But because we created this substitution value here, you could have chosen U or you could have chosen T. It doesn't matter which one you substitute for. You just drop it in. So we chose T. So I dropped it in for everywhere there was a T. And then I just solved for U. And then after I solved for U, I'm able to take it back up here to T equals, sub it in for the U, and then find the value of T. And then that allows me to create my original number by putting those two numbers in their proper location, in their original location. All right, if you have any questions about that, please let me know. That is all I have for lesson 107. I'll see you in lesson 108.